Bonding essay question 9. So in question 9, it talks about nitrogen trifluoride. Part A, I've already gone through this in your atomic structure, and once again, it's no difficult stuff. It's also your covalent bonding. By now, you should be quite familiar with it. Now let's look at 9b. Comment and explain the electrical conductivity of nitrogen trifluoride. You by now should know that nitrogen, non-metal, fluorine is also a non-metal. So we are talking about covalent substance here. So for covalent compounds such as nitrogen fluoride, it cannot conduct electricity in any states. Why is it so? It's because they does not have any mobile charge carriers. So there's two main points here. First, you must say whether it can or it cannot. Then you must explain why. So there's a comment here and there's an explanation needed. So please take note of this little difference. Next up, part C, they ask, would you expect the boiling point of nitrogen tribromide to be higher or lower than -129? So in actual fact, if you look at 9C, most of the U secretaries have not learned yet. So how do you know? Okay, so what's the correct answer actually? It will have a boiling point higher than that of -129. Because if you look at group 7, which you'll study in periodicity, they belong to the halogen. And the melting and boiling point of each element increases down the group. So if bromine is lower down in the group than fluorine, so you expect the boiling point to be higher. However, as you can see here, I state here that I personally do not agree that this is necessarily a good answer. But because of what is covered in your syllabus, I think this is the best explanation you can give. The correct answer is actually because the molecule of NBr, okay, NBr is heavier and bigger. So the intermolecular force of attraction is stronger, okay? The molecular force of attraction is stronger. Now, you will cover this when you go on to poly or JC. So don't worry so much about this. Just take note of this. The bigger or the heavier the molecule is, the stronger the intermolecular force of attraction for covalent compounds. Now let's look at 9D here. Okay, nitrogen trifluoride, we have hydrogen chloride. They give you nitrogen, chlorine, and hydrogen fluoride. Balancing equation. How you can go about doing this, you can start from any one side. In this case here, let's start from nitrogen. So I have two nitrogens on the right hand side, whereas initially, if you want to rewrite the whole thing, it initially looks like this. Erase this. So initially on the right hand side, I have two nitrogens, but on my left hand side, I only have one nitrogen. So I put a 2 here to make sure that the nitrogen on the right is balanced with the nitrogen on the left. So once I'm done with that, I realize I've tipped fluorine. So I have 6 fluorine here, 1 fluorine here. So I need 6 over here. When I inserted a 6 over here, I affected the number of hydrogen. So hydrogen now have 6. On this side, I require 6. With 6 hydrogen here, I also have 6 chlorine. So left hand side I have 6 chlorine, right hand side only 2, so I multiply here by 3. So therefore the final answer is here. You realize in terms of balancing, you'll go left, right, until it reaches a balancing point. Do not worry so much about balancing equation because it's somewhat like a trial and error method. Once you have done enough of it, you realize that the answers come in quite easily. So do practice more with regards to balancing equation.